Hello everyone, this is going to be the question number 1 in your collision for response homework. So let's get started. So first of all, it's really important to understand that question and understanding the graph. So I put more information than what the question gives you on the picture. So you have a boat and there's a bumper and there's a shock absorber over here. So what happens, this guy hits to the docking bumper and then it basically slows it down. And the mass of the boat is 2 times 10 to the power 5 kilograms. And it's important to understand this graph because this is making it a difficult question or look like a difficult question. So this is velocity time graph of the boat. So it is having this velocity curve at the beginning, and once it hits that bumper, it's going to have 3 meters per second. Then it's going to go down to 2 meters per second, and then they're going to go down to 0 meters per second, but it's going to have a different curve. So when you read the question thoroughly, then you will see that the curve, the equation for this curve is 2 times e to the power negative 4t. And your velocity over here, they give it as, in part C, 1 over v. They give it as 1 over v, and they don't have those t parentheses, but t meaning v, velocity as a function of time. And over here, again, v as a function of time. In the question, they are just given as v equals 2 times e to the power negative 4 t. And in the question, again, this is given as 1 over v equals 1 over 3 plus beta t. But I decided to put this as vt equals 1 over 3 plus beta t, but I would like to have that negative power to make my calculations easier. So that's basically the question. So now let's see how we solve this question. In part E, what they say is this boat and the bumper or docking bumper, they hit, and after they hit, they are basically going with 2 meters per second. So what can be, and it's an inelastic collision, and basically they are moving together. So that makes it perfectly inelastic collision. So then we will just have our conservation of momentum equation. So m1v1 initial, m2v2 initial must be equal to m1 plus m2 v final, because they hit and they stick together, so they're going to have one common velocity after the collision. So now we will just plug in the numbers. So mass of the boat is going to be 2 times 10 to the power 5. Initially, it tells you in the question when t equals 3, again that is kind of confusing, but this point is t equals 3 seconds point, it's not a 0 point. So when t equals 3, the boat is going to have 3 meters per second velocity. So 3 plus m2, the docking bumper is at rest at the beginning, and we do not know what that mass is, but it's not important, times 0 plus, actually let's put m2 times 0, and m1 plus m2, we do not know m2, but we know that this guy is 2 times 10 to the power 5 plus m2 is unknown, and v final, they tell us they were going with 3 meters per second, and after the hit they are going with 2 meters per second, so my common velocity is going to be 2. So once you do the math over here, this is going to cancel out. 2 times 3, so that's 6 times 10 to the power of 5, and that's equal to what? I would like to keep this as it is right now, and you will see why. m2 times 2. So now I can, you can see this is a parenthesis and this 2 is outside of the parenthesis, so that means I can simplify this 2 and this 6. And then this is going to have 3 right here, so we can multiply this and this because this there's an parenthesis outside. So what is this going to do? What is this going to give you? 3 times 10 to the power of 5 equals 2 times 10 to the power of 5 plus m2. So over here, what can we do? We can subtract 2 times 10 to the power of 5 from both sides, or you can see that over here, 3 times 10 to the power of 5 equals 2 times 10 to the power of 5 plus, so it's basically 2 plus 1, because you see, think that 10 to the power as an apple, so 3 apples equals 2 apples plus another apple, so that gives you that m2 equals 10 to the power of 5 kg. Alright, so this is the mass of the bumper. Alright, now let's move to the calculus part. So this is actually the momentum part of the question. The rest is kind of about force and kinematics, and actually mainly kinematics. Alright, so in part B, they say that after they bump, velocity of that boat is basically, it's a function. It's not going at a constant speed. So that function is 2 times e to the power negative 4t. And then they are asking for the position, or they're asking for the distance that's going to take for this guy to go from that bump point to like the stopping point. So what can be the distance for that? So basically they're asking for delta x. So now we need to remember that delta x and velocity, the relationship in between them, if you're trying to go from position to velocity, you need to integrate the velocity function with respect to time. So basically that is the idea of time. I mean, this is the idea of like position and velocity relationship. So now all we need to do is plug in this function in terms like into this vt function and solve this for basically x function. Alright, let's see, x will be equal to what? So we are going to put our integral, and then we're going to have 2 to the power of 2 times e to the power of negative 4 t dt. Alright, so that is an important part of the question. So now we need to decide my time interval. Alright, so it's really critical that we are going to plug in the numbers correctly. So I am trying to figure out the displacement over here. So I am going to choose this as like starting point, starting time, and this is going to be my ending time. So mathematically, you are going to start from 0 second time, and this is important, you're going to go to infinity, because mathematically this guy is going to end at infinity, because if you put anything else, you are not going to actually have like you're not going to reach to your final point unless you put infinity over here. That's a little bit too much, but basically that's how you need to approach to that question. So now we know our borders, and then we are going to solve this question after this point. So now, how can we take the integral? You have a constant, so you can take this out of the integral. So it's going to go to 0 infinity e to the power negative 4 t dt. And if it was just e to the power t, that would be easy, but now you have 4t, so that's also another like function. So the way to integrate that, you just put u for the powers. So 4t, that negative 4t, we call it u. Then we are going to take the integral of this u with respect to time, so du over dt, and that is going to be equal to what? What's the integral? I mean, what's the derivative of negative 4t with respect to t? It is negative 4. Then what's the relationship in between du and dt. Du equals negative 4 dt. Or if you would like to write this one for dt, your dt will be equal to negative du over 4. Alright, so this is basically dt replaced with negative du over 4. So now let's do this, continue from here. We did the substitution. So our integral will become 2, 0, infinity, e to the power u. So dt will be replaced with negative du over 4. So now if you would like to take one more step, this negative 4 or negative 1 over 4 can be taken outside because that's also a constant. So my integral will look like 2 times negative 1 over 4 and then integral 0 to infinity e to the power u du. Alright, so now this is an easy integral. So we will do the math outside as well. So negative 1 over 2. So what's the integral of e to the power u with respect to du? It's just going to be itself. So that will come out as it is. So it's going to come out as e to the power u. But remember, once we go out, we are going to replace this u with itself, which was negative 4t, and then we are going to put that in the boundaries 0 and infinity. So now as you can see, the number came out, so that guy came out of the integral. All we need to do is plug in the borders of that into our equation. So now our x is equal to negative 1 over 2, actually that's also in the parentheses. So we are going to have e to the power, again, first upper boundary first minus lower boundary, e to the power negative 4 times t. Instead of t, what do we put? Infinity minus, that's also outside of the parentheses, minus e to the power of minus 4 times 0, close the parentheses. So now, what do we have? This is going to be equal to 1 over 2. Alright, this is going to be easy because negative 4 times 0 is 0. So e to the power 0 will be 1. And this is a negative power, so I will just put this guy as, and 4 times infinity is again infinity, so it's going to be e to the power infinity. So it's going downstairs because it's a negative power, and remember, negative power is basically going in a denominator. So 1 over e to the power infinity, because any number times infinity will give you infinity again, minus 0 times any power is 0, e to the power 0 is going to be 1. So this is our basically equation. And now, what is e to the power infinity? So you're taking, you're multiplying infinite e's, and remember, e is just a number, so you're multiplying infinite numbers of, I don't remember, but 2 something, so 2.4, something like that. So if you multiply infinite numbers of those, you're going to get an infinity. So this part will also be infinity. And then what are you going to get? 1 over infinity. So if you divide 1 to an infinity, then what are you going to get? You're going to get 0. So 0 minus 1 will become what? Negative 1. So your x at the end will become negative 1 times negative 1.5. So it's going to become 1 over 2 meters. So as you can see from this function, you can actually get a number. So it's going to take half a meter for this boat to stop completely. So that's part B. For part C, I have to erase this part. So for part C, they are asking for the force, and we should remember that force equals mass times acceleration, and that means it's mass times dv over dt. So, but they're asking for that force as a function of velocity, so that is going to make things a little bit tricky because it's going to look weird. So, alright, so mass times dv over dt. So, my v function, again, 1 over v is given as 1 over 3 plus beta t, but I am going to change this 1 over v to just v, and to be able to do this, I need to flip both sides, so I just put this negative power over there. So, my dv is simply dt is over here, 1 over 3 plus beta or beta t to the power -1. So that means m is just a constant, so it's not going to be important. So I need to be able to take the derivative of this function. So, and I'm trying to take the derivative of this function with respect to time. So there's no time unit over here, but there's a time unit over here, so there's a beta in front of it. And that is under another power. So to be able to do this, think about this. Let's say if you had only x to the power -1, how would you like that's just an example. If you had x to the power -1, the way that you would take the derivative would be put that power to the front and then lower the power by 1. So that would give you x to the power -2, right? So we're going to have a similar thing, but we also have a function inside. This is not just x, it is 1 over 3 plus beta t. So we also have a function in front of t, so what should we do? We should take the derivative of inside as well. So if you take the derivative of inside with respect to t, no 2 units, so that's going to be 0, and the derivative of inside, derivative of beta t with respect to t, will just be beta. So then at the end, what are we going to put? M, that was already there, times derivative of inside is just beta, so we also include this, times derivative of this guy itself. So it was x to the power -1, so take this as one part, like one thing, and it's just your x. So you put that -1 in front, so this -1 comes in, and then you lower the power by 1. So your x in this case is again 1 over 3 plus beta t and power 2. Alright, so as you can see, this part is just like this, but since you have this beta in front, you need to take the integral, derivative of inside as well, so that's where this beta comes from. And now, if you would like to write this one down more clear, so this is a -1, so that's just a number, and it's going to make the entire equation negative. So it's negative m beta times 1 over 3 plus beta t minus 2. Alright, so this is my answer right now, but what do they ask for? They ask force as a function of velocity. This is not a function of velocity, this is a function of time because you don't see a velocity. But what do we have? We have velocity here. And if you look at this, v as a function of time is very similar to this. What's the only difference besides this? You don't have power of -1, you have power of -2. But we can have a simple math trick over here, and then we can call this negative m beta keep the left side same because that's not going to do anything with this right side. So instead of power -2, let's do it this way. Put this as power of -1, and then basically organize this a little bit differently. So take the square of this power. So at the end, they are the same thing. It's just a different way of writing it. So then, as you can see, we have this v function exactly. So you see, so that's why we did this trick, because we are trying to write this equation in terms of v. So we are trying to find v, and that's what it is. And if you finalize it, your force as a function of velocity will become -m beta v, because this is v itself, and then you have a square over there. So it is going to be force as a function of velocity. Alright, that seems a little bit tough, and it's a little bit tough, but the good news is that's an old question, and they're not asking those kind of like heavy math questions, but that doesn't mean that they are not going to ask that again. So just in case, I just want to put that question in your assignment as well.